So problem two, we're asked to prove that the triangles are similar. And here what I notice is I've got two sides. I've got this small side 5, and I've got the corresponding smaller side 20. And then I've got this larger side 40, and this larger side. So I'm going to circle my small, box off my large. That way when I go to do the ratios, I know what matches what. The third piece of information we need, because when you do proofs, you're usually going to need 3 pieces of information. We'll talk about the 2-piece information probably on Thursday. But the third piece of information they give me is this angle here, which they tell me is 52, and here's a corresponding angle that's also 52. I can tell those angles correspond because they're in the same relative position. They're both sandwiched in between the red and the blue sides, which is what I want for a side angle side proof. That side should be in between your two sides. And you can also use the similarity statement to tell that those angles correspond. So angle A, the first letter, should correspond to the first letter, angle K, of the other triangle. That's how I can see they correspond. So here is a side angle side proof, right? That angle that we're going to use is in between our two proportional sides. So I think I'm ready to write my proof, but I'm going to write my ratios first. So my ratio is going to be this side BA, right? BA over the corresponding side LK. And that would be 20 over 5, which turns out to be 4. And then my other ratio is going to be AC, right? AC over the corresponding side MK. And we're going to get 40 over 10. I almost made a mistake. I almost put the 10 on top. You have to be consistent, right? If you have a big over the little, you got to do the same thing over here, big over the little. That order matters. And that is also 4. So I'm ready to write up my proof. I'm going to start with 1. I'm just going to write this similarity statement for the sake of time. I'm just going to move it over like that. My reason for writing that is the ratio of corresponding sides. Right? I'm evaluating those corresponding sides using a ratio, and I'm seeing that they equal a number. My second thing is this ratio of corresponding sides. Okay, so I've got side, side, and now I need an angle, or a third side, but I know nothing. I know nothing about that side. I know nothing about that side. So I can't make the statement that these sides have a ratio of 4 because I have no reason to say that. So that's what the proofs are about. It's like, what can you say? What I can say is, well, if you look at the angle opposite that third side, that angle sandwiched in between my two so far proportional sides, I can tell you that those angles are congruent. I can tell you angle K, that angle right there, is congruent to angle A. Well, how did I know that? Oh, that was given information. You can just look at the diagram they provided you. And that's why we're getting rid of that first step of saying, oh, the diagram is provided. How did I know that it's given? That's just assumed. You're eventually going to, in the proof, use that diagram. And whenever you use something, whenever you don't have to do any math or cite a theorem or some angle relationship, that's called given. So I've got my 3 facts. I'm ready to make my statement. So I'm going to say 4, and I'm going to copy that similarity statement. Triangle ABC is similar to triangle KLM. It's important that you copy it because, like we saw earlier, the order of these letters matter. They are the corresponding parts. That's how I can tell side LK, the first 2 letters, corresponds to side AB, the first 2 letters. So that's another way you can pick out corresponding parts to use in your proof. And what's my reason for making this claim? Well, that is the side-angle-side similarity theorem. And we're done. I'll see you in the next one.